Welcome to True Projects. In this video, we are going to explain about a project titled Diabetes Disease Prediction using Machine Learning Algorithms. The project focuses on predicting the diabetes disease using various supervised machine learning algorithms like KNN, Naive-Bayes, Decision Tree, Random Forest, and SVM. Have integrated all the relevant risk factors present in the dataset to achieve a robust accuracy through the classification and the cross-validation. The primary aim of the project is to identify the most potential result in terms of accuracy and computational efficiency for predicting the diabetes disease. The introduction discusses the diabetes as a condition that leads to the elevated blood glucose level due to the insufficient or the low level of insulin. Detecting and predicting this disease can be challenging but not impossible even at its early stage. The researchers have analyzed why certain machine learning classifiers need not provide the consistent and accurate result. They visualize the training and testing accuracy and examine the potential issues like model overfitting and underfitting. The objective of this project is to discover the most optimal approach, achieving both the higher accuracy in predicting the diabetes and minimizing the computational time for more efficient and the reliable disease prediction. By using the various machine learning techniques like of K-nearest neighbor, Naive-Bayes, Decision Tree, Random Forest, and SVM as used to achieve the stable accuracy of the classifying and performing the cross-validation. Here, our project mainly estimates and finds to more relatively gives the accuracy and the computational time for the diabetes disease prediction. And these are the basic requirements that are needed to build this project. The software requirement: Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements: operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, we need to discuss these steps. The first one is importing the libraries. In this step, the essential Python libraries such as NumPy, Pandas, sklearn, Keras, Flask, and Matplotlib are imported. These libraries are crucial for the tasks such as data manipulation, data pre-processing, machine learning, model building, visualization, web development, and creating of comparison graphs too. And the second one is exploring the dataset. The dataset as in the CSV file format is explored to gain the insight into its structure and the contents. Here, the dataset contains of the number of pregnancies, age, gender, blood pressure, insulin, and many more. And the exploratory data analysis is performed to understand the distribution of data, detecting any missing values and visualize the relationship between the variables. And the third step is data processing. Data processing involves cleaning the dataset, handling the missing value, and preparing it for the model training. Feature engineering techniques are applied to derive the meaningful features or to transform the existing ones. Data processing ensures the data is in suitable format and free for any regularizations that could affect the performance of the model. And the fourth step is splitting the data to the training and the testing. To evaluate the model performance accurately, the data set is split into the two subsets, the training set and the testing set. The training set is used to train the machine learning model, while the testing set remains unseen and is used to assess how well the model generalizes to new and unseen data. And the fifth step is feature extraction. In this step, the specific feature extraction algorithms are applied. The first one is recursive partition algorithm. The recursive partition algorithm, also known as recursive feature elimination, is a feature extraction technique that recursively removes the less important features from the dataset and works by training the model on the entire set of features and then ranking the importance of each feature based on their contribution to the model's performance. The least important feature is removed and processed until the desired number of features is obtained. And the second one is process component analysis, is a dimensionality reduction technique used to transform the high dimensional data into the lower dimensional subspace while retaining the most significant variance in the data. It achieves this identity the principal components, which are linear combination of the original features that capture the more variance in the data. The higher ranked principal components represents the most essential information, while the lower ranked ones capture the less significant variations. And the KNN-Nyberg classifier on the 14 different attribute sets. In this approach, the KNN classifier is applied on the 14 different attribute sets, each containing a different combination of features from the dataset. The KNN algorithm measures the similarity between the instances in the dataset based on the selected features and assigns a class label based on the majority class among the k nearest neighbors. By using the different attribute sets, the algorithm aims to identify which combination of the yield gives the best predictive performance. This helps in selecting the most relevant features for the model and discarding the less informative ones. And the sixth step is building the model. The several machine learning models are built on the trained dataset. The first one is Naive-Bayes. It is a probabilistic algorithm based on Bayes' theorem, which calculates the probability of the particular instance belonging to a certain class. It assumes that the features are conditionally independent given to the class label, making it computationally efficient and well suited for high-dimensional dataset. The second one is SVM. The support vector mission is a powerful algorithm for both the classification and the regression task. It works by finding the hyperplane that best separates the different classes in the feature space, maximizing the margin between the classes, where SVM is effective for dealing with high-dimensional data and handle both the linear and the non-linear classification tasks through the use of kernel function. And the third one is decision tree. Is a tree-like model where each internal node represents a feature, each branch represents a decision based on that feature, and each leaf node represents a class label. The algorithm recursively splits the data based on the most informative feature, resulting in a tree structure that can be used for the classification or the regression task. And the fourth one is random forest. It is an ensemble learning method that combines the multiple decision tree to improve the performance and reduce the overfitting. It creates the several decision tree during the training and combines the prediction through the majority voting and averaging. Random forest is a robust, scalable and less prone to overfitting than the single decision tree, commonly used in applications such as of the gene expression analysis and of any detection tool. And the fifth one is KNN. KNN stands for K nearest neighbor, is a simple and initiative algorithm for the classification and the regression task. Classifies an instance by identifying its K nearest neighbor in training data, taking a majority vote or averaging of their labels, where KNN is a non-parametric, meaning it doesn't make assumptions about the underlying data distribution and handle the multi-classification problem. And the seventh step is comparison graph is created to visualize and compare the performance of the different models. This graph helps in understanding which model performs the best for the given task. And the eighth step is training the model. The machine learning model are trained using the training dataset. During the training, the models learn from the input data and adjust the internal parameters to make the accurate prediction. And the ninth step is user gives the input. Here, the web application is created using the Flask framework, allowing the user to input the data for the prediction. The Flask interface provides a form where users can enter the relevant input data. And the 10th step is the given input is pre-processed for prediction. Here, the user input data is pre-processed to match the format used during the model training. This involves scaling, normalization, or necessary feature transformations. And the 11th step is trained model is used for prediction. With the pre-processed user input, the trained machine learning models are employed to predict the final outcome. Each model processes the input using the learned parameter and produces the prediction based on the feature extracted. The final outcome is displayed. The prediction outcome is displayed to the user through the Flask web application. The user can see the model classification, providing the valuable insight for the decision making. And the execution of the project. To execute the project, first we need to open the code folder. and this is the code folder containing of the various data files within it. The static folder containing of the various images within it, and of template folder containing of the HTML documents like of index and result within it, and the apps and py file containing the information related to the front-end logic. It includes the code in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And the diabetes disease prediction using the machine learning algorithm is an IPYNB file, contains a combination of the code, graphs and output all in one place that allows the user to write and execute the code in the individual cells, making it a popular choice for the data science. And this is the diabetes dataset which we use it for this project. And the model.pkl is an model file which contains the algorithm information, and it loaded at the time of execution of the project and doing certain operations like of predicting the new data. And to execute the project, we build an Flask framework as a web interface, and the whole code is present in the IPYNB file in the form of graphs, output and code. For the execution of the project, first we need to select the copy of the code folder address and then open the Anaconda prompt. Here first we need to change the disk location as F because our code folder is present in fdisk. Then write a command cd space and paste this address of the code folder. By this, the directory will be changed to the code folder's path, and then click on enter button. After this, we need to write another command python space app.py. This command is used to execute the project Python script and perform a runtime check for any syntax errors or the logical issues, and then click on it. After running the app.py file, the Flask framework will host the application locally by giving an address to it. Here we need to copy this local link and enter this local link on any on the web browser. I prefer to use the Google Chrome, and then click on enter button. Here we redirected to this home page containing of the different features within it, and the number of pregnancies of 2, and the glucose level is of 124, and the blood pressure is of 87, and skin thickness of 24, and the insulin level is of 145, and the body mass index is of 22, and the diabetes pedigree function is of 24, and age of 21. And by clicking this predict button, we can predict whether the person is having the diabetes or not. Here we can see the screen as wow, you don't have diabetes. And by clicking the back button and refresh button, we can enter the other details too. Here I am entering the number of pregnancies is of 5, and the glucose level is 166, and the blood pressure is 72, and the skin thickness is of 19, and insulin level is 197, and the body mass index is of 25.8, and the diabetes pedigree function is of 0.587, and the age is of 54. And then clicking the predict button, we can get a result of oops, you have diabetes. In this way, we can predict whether the person is having the diabetes or not by using various machine learning algorithms. And in conclusion, the project concludes that the prediction of the diabetes disease is possible using the machine learning algorithms of using various supervised learning algorithms, namely the KNN Neo-based decision tree, random forest and SVM, to achieve a stable accuracy after classifying and performing the cross-validation. We have incorporated all the present risk factors of the dataset to achieve the most optimal result in terms of accuracy and computational time for the diabetes disease prediction. The project's main goal is to find the most optimal result in terms of accuracy and the computational time for the diabetes disease prediction. The project suggests that this model can be implemented into the system to predict the other deadly diseases as well.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.